Alright, so this was number 3 from section 1. And so I'd mentioned in the video that 64 is just another way of saying 64 cubed. One way that you could try to figure these out is if you have a base of 4 over here, see, 4 squared, 4 cubed, what would those values equal, and are they equivalent? But 4 cubed is 16 times 4, so that gives me 64. And then I would have, using this one-to-one, if my bases are the same, that means my exponents are the same. So I just have x minus 9 equals 3, and I solve for x. On the number 8, number 8's problem was e to the x squared plus 30 equals e to the 11x. And so this is similar. It's one-to-one because my bases are the same. That means my exponents have to be the same. And then we're just solving a quadratic equation to find those values of x that make it true. Subtract your 11x over, factor, and then we get solutions of x equals 6 and x equals 5 to make that true. The last one had that fraction in it. It was a 1/2 to the x equals 32. Again, powers of 2 may pop up a lot, but 1/2 is the same thing as 2 to the negative 1, and 32 is the same thing as 2 to the 5th. From here, make sure we have the same base. When you have a base with an exponent raised to a power, you multiply your exponent and power. So I would just get 2 to the negative x equals 2 to the 5th. My bases are the same, so that means my exponents have to be the same. So that would give me x equals negative 5. So when you're doing these, you just have to be able to manipulate your numbers a little bit. This one had a negative exponent. That one had a just a number we had to figure out. Same thing with this one. 4 to the x minus 9 equals 64. We could put this all in powers of 2, because it's 2 squared is 4, and then 2 to the 6th is 64. So that means I would have 2 to the 2x minus 18 equals 2 to the 6th, and now I'd set 2x minus 18 equal to 6, and we get that same answer of 12 if we solve that. So it's being able to manipulate your bases.